Okay, which of the following could be the average time for the 15 people shown in the histogram? Well, okay, this is a histogram, so it's very much like a frequency table. If I want to calculate an average, I've got to calculate a sum divided by a count. But remember, my sum is actually going to be the product of the number of values times the category value, which would mean, say, for the first one, and here's part of the problem, what is the value for the category? It's not just one value. It's actually a range of 30 to 60. So I'm going to calculate a low total and a high total. My low total would be 30 times the count of 2. That would be 60. 60 times the count of 4 is going to be 240. 90 times the count of 3 will be 270. 120, I'll multiply by, well, there's just one, so it's 120. And 150, there are 5 of them, so that could be 750 on the low end. So these are the low ends of my totals for each category. So if I want my low sum, that's going to equal 60 plus 240, or 1,440 in total. Now, I could also be at the high end of the range in each category. This would give me the maximum total possible. There, I would do 60 times 2, which is 120. 90 times 4, or 360. 120 times 3, which is 360 again. 150 times 1 is 150. And 180 times 5 is going to be 900. So my high sum is going to be the 120, or a total of 1890. Now, I need to know what the average time would be. So I'm going to divide by the count of 15 people for each of these. So let's check my low and high. So my low average is the sum 1440 divided by 15. My high average is 1890 divided by 15. And that low, 1440 divided by 15, is going to be a little less than 100. Works out to exactly 96. The high is going to be 1890 divided by 15, which is going to be a little more than 120. Works out to 126. My answer must fall within the range of 96 to 126. The only answer that's within that range is 123. The others are above or below. So the correct answer here is option C, 123. F of x minus y equals f of x minus y. Okay, this could cause students confusion on where to begin. Very unusual function question. We are given something that students probably recognize more easily off the bat. F of 3 equals 10. Okay, that's more recognizable. Hopefully students see that and can understand that. That means if I put in 3 into my function, I somehow get 10. Okay, well, here's the challenge. Can I somehow take what I know and put what I don't know in terms of what I know? That's a general approach for a lot of problems on the exam. So how could I do that maybe here? Well, I do see f of x, which that looks like that. So I could probably make that f of 3. And I'll do that down here in blue. In which case, my first function equation becomes f of x minus y is f of 3 minus y equals the f of 3 minus y. And they tell us f of 3 is 10, so that really becomes 10 minus y. Okay, we're getting somewhere. I've got f of 3 minus y equals 10 minus y. Still a little confusing, but what can I do here? Well, maybe I can guess a number for y that will make what I need to find, and I need to find f of 6. So in other words, what y could I plug in here that makes this f of 3 minus y f of 6? Well, that'll occur if y equals minus 3. 3 minus minus 3 is f of 6. So if I guessed y equals negative 3 and plug that into my blue function, I will get f of 6 equals 10 minus y. But I also know y because we just said it's negative 3. So it's 10 minus minus 3, which is 10 plus 3. Aha! It all came together. F of 6 equals 13. That's the answer. So how do we do this? How do we actually approach starting somewhere where we couldn't start on a confusing question? Take something that you think you know and understand and maybe try and put what you don't understand in terms of what you do. And maybe with a little work and a couple different steps, you'll go down the right pathway and get toward the answer. Better than sitting there like a deer in the headlights.